Hey there, in this video we're going to continue with the first derivative test, or the increasing decreasing test, to find the intervals where a function is increasing decreasing and finding any local extrema, local max, local min. So this is our second example, part 2 of the videos. So determine the intervals where the function is increasing and decreasing. So first off, how do we find, as soon as you see increasing decreasing, that means find the derivative, set it equal to 0. And then go from there. We need to find critical numbers. So the first thing is find critical numbers and remind yourself, what are critical numbers? That's where the derivative is 0 or undefined. Whenever you have fractions, then that means the derivative is 0 when the numerator is 0 and the derivative is undefined when the denominator is 0, right? Because the denominator, when you have fraction, denominator can't be 0. So find critical numbers. And how do you do this? You find f prime and then set f prime equal to 0. So let's look at our function. F of x is x squared over x minus 1. So then f prime of x is, we're going to use the quotient rule. So bottom, so x minus 1 times the derivative of the top, which will be 2x, minus the top, x squared, times the derivative of x minus 1, which is just 1, all over the bottom square. Again, be careful not to want to say like, oh, I can cancel this x minus 1 with this x minus 1. You have a big subtraction here, so you have to simplify that numerator first. So let's distribute this 2x in. So I'm going to have 2x squared minus 2x and then minus x squared over x minus 1 square. Simplify completely. And the reason we want to simplify completely is because we are wanting to set this equal to 0 and solve for x. So 2x squared minus 1x squared is just x squared minus 2x over x minus 1 squared. And simplify some more, factor out an x from the numerator. So this is our simplified derivative. Can I simplify anymore? No. So then set it equal to 0. So now the derivative is going to be 0 when the numerator is 0. So f prime of x is 0 when x times x minus 2 equals 0. So that means when x is 0 or when x is 2. And the derivative is undefined. So f prime of x is undefined when the denominator is 0. So when x minus 1 square is 0. So that just means when x minus 1 is 0, square root of both sides, which means when x is 1. So I have 3 critical numbers. So that's going to split up or realign into intervals. And then we can use the first derivative test. So let's put our number line and our critical numbers. So 0, 1, and 2. And for me personally, I like to know what my derivative is doing at these critical numbers. So at 0 and at 2, the derivative is 0. And at x equals 1, my derivative is undefined. And so the undefined is, so why is it undefined? So notice that here the function, I did say in the previous video, was find the domain first, and then I didn't do it here. Notice that here the domain is that x cannot be 1. So the domain is minus infinity to 1, union 1 to infinity. And this doesn't cancel with anything in the numerator, so that means that at x equals 1, you have a vertical asymptote. So the function itself is undefined at x equals 1 because you have a vertical asymptote. So that's why the derivative then is undefined. So we are not going to have, this isn't going to be a max or a min because there's no y value in the function. Had it been undefined because it was a corner or a cusp, I could potentially have a local max or local min there. Think absolute value of x, right? The derivative is undefined at 0, but that is the minimum of the function. But here, the derivative is undefined because the function itself is undefined. So this is neither going to be a max nor a min. So the domain kind of helps us see also what about why, if our derivative is undefined somewhere, is that undefined because we have a corner or a cusp, or is it undefined because the function itself is undefined? In this case, because the function itself is undefined, I know there's not going to be a y value for this, so I can't have a max or a min there. Okay, so let me just make a quick note about that. So this, we can say x equals 1 is not in the domain. Then I know, right, it can't be a max or a min. All right, so now let's go figure out our test points. So pick a test point from each interval and then see what it does. So we have how many intervals? So 3 critical numbers. So 1, 2, 3, 4 intervals. So I'm going to have the interval from minus infinity to 0, and then 0 to 1, and then 1 to 2, and 2 to infinity. So these are my intervals. And then pick your test point. So try to create a cleaner way of doing this with a little table. So our derivative is x times x minus 2 over x minus 1 square. And so picking a test point between minus infinity and 0, you can pick, say, negative 1, right? And these are x values. Plug them into the derivative. And again, we don't necessarily care too much about the value, but we really care about the sign. Is it positive or negative? If the derivative is positive, I know the function is increasing. If the derivative is negative, the function is decreasing. So don't worry too much about the value more than the sign. So when x is negative 1, I'm going to have a negative times a negative 1 minus 2, that's negative, over, notice that the bottom, regardless of the value of x here, this is quantity square, so this is always going to be positive. So negative times a negative is positive over positive, that's positive. And so I usually like to put in my derivative right away. So that's positive, which means that the function is increasing. And now let's go to the next test point. So when x is, so between 0 and 1, so pick 1/2, 0.5 if you want to change it to a decimal. So you're going to have x is positive 1/2, so that's positive, and then 0.5 minus 2, that's negative, over, we said the bottom is always positive, so I have a positive times a negative is negative divided by a positive, so that's negative. So my derivative here is negative, which means that the function is decreasing. So I will go from increasing to decreasing. So what sort of a thing do we have at 0? Yeah, this is going to be a local max. And let's keep going. So for between 1 and 2, you can pick x equals 1.5, and so you're going to have positive 1.5, so positive 1.5 minus 2, that's negative, over positive, so that's going to be negative again. So negative, and which means the derivative, well, the derivative is negative, which means that the function is decreasing. So, but we already know that 1 is not in the domain, so decreasing, it doesn't give us anything anyway, right? It's not a local max or a local min, but regardless of that, it's not in the domain, so it wouldn't have helped us. And then between 2 and infinity, pick something there bigger than 2, so let's say 3. X is positive, so I'm going to have positive, and then 3 minus 2, that's positive, over positive. So I get the derivative there is positive. So back to my number line, this is positive, which means that the function is increasing. So what do we have at 2? You go from decreasing to increasing, so this is going to be a local min. Now, how do we find them? We put them back into the original function. So let's say we, based on the number line, we know we have a local max at, what was it, at x equals 0, and we have a local min at 2. So what is the local max? So to find it, then we plug it into the original function. So f of 0 is the maximum, right? The local max value. So plug it into the original function. So f of 0, original function was x squared over x minus 1. So when you plug in 0 there, you have 0 squared over 0 minus 1, so it's just 0. So we have a local max at 0, and we have a local min at x equals 2. So f of 2 is the value of the local min. So plug it in. So what is f of 2? F of 2 will be 2 squared over 2 minus 1, so 4. So that's the local min. And then we still need to answer where the function is increasing or decreasing. So we can say f of x is increasing on, let's look at the interval. So let's go back to the number line. Or you can see it just from the table here. So wherever we have a plus for the derivative, that's where the function is increasing using the first derivative test. If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. So then looking at my table, I can see plus, so it's increasing on minus infinity to 0 and 2 to infinity. Or I can look at my number line, minus infinity to 0 and then 2 to infinity. So we can say it's increasing on, and then just list out the intervals. Minus infinity to 0, union 2 to infinity, and then f of x is decreasing on then 0 to 1, right? But notice 1 is not even the domain, so I have to make sure that I say 0 to 1 and then 1 to 2. Be careful not to say just 0 to 2 because 1 is a critical number, so you have to pause there. So 0 to 1, union 1 to 2. So that will be depending on what you're being asked, right? Increasing, decreasing intervals, this will be our answer. I will ask for the local max or the local min, then this will be the answer. And pay attention again, kind of with the absolute max and min. Are you asked for the y values or where do they occur? So if in this case, I've listed both. So the local max occurs at x equals 0, but the local max is f of 0, which in this case is 0. So this is the same. But for the local min is a better example. It occurs at 2, but the local min is 4. And so you might be thinking like, but 0 is smaller than 4. How is that a max and how is this a min? Remember, this is an absolute max. Absolute is then we're looking at the values in terms of largest and smallest y values, but local max and local min just refers to the peaks and valleys. So essentially what this is saying is that at 0, 0, we have, this is a local max, so then this is a peak in the graph. And at when y is 4, so at 2, 4, you have a local min, so this is a valley. So meaning that your function probably does something like this. So at 0, you have a peak, and then at 4, you have a valley, although they should be reversed based on, let me try again. We do have a vertical asymptote at 1, so that's probably why it looks like that. So at 0, right, you have a peak, and at 4, not drawn to scale, and this is just an example, not the actual graph of the curve, and this will be a valley, right? So that's what we mean by a local max and a local min, is that you have essentially peaks and valleys. So this is different than saying an absolute max and an absolute min, where you're looking at the actual comparing the actual y values. All right, let's try our next example. Find any relative extrema of the function, this function, and relative extrema is the same thing as saying local max or local min. So when you see that, that means find local max and local min. So to find local max and local min, or intervals of increasing, decreasing, we have to find critical numbers. So let's find the derivative and set it equal to 0. So find f prime of x and set f prime of x equal to 0. So let's find the derivative. F prime of x here, so sine square x, so I can write that as sine x quantity squared. So that's what that means, right? Or you can say sine x times sine x. I'm going to write as sine x quantity squared so I can use the chain rule. Instead of, if I say sine x times sine x, then I'll be using the product rule. So let's see. So chain rule, so bring the 2 down, so it's 2 sine x, right, the inside left alone, times the derivative of the inside by the chain rule, which is cosine, plus the derivative of cosine is negative sine, so really minus sine x. And then set it equal to 0 and solve for x. I see both of them, both terms have a sine x, so we can take the sine x out, and I'll be left with 2 cosine x minus 1 equals 0. This problem may look familiar. It was on the last test, but it was just finding the derivative, so now we're using it as an application, or with an application. So set it equal to 0, so either sine x is 0 or 2 cosine x minus 1 is 0. This tells me, right, solving trig equations, solve for the trig function. So cosine x is equal to 1/2. And this does tell me find any relative extrema on that interval. So I am given an interval, but be careful, right? It's still asking for a relative extrema, not for absolute extrema. So I still want to find my intervals of increase and decreases and find local min and max that way. All right, so when is x equal, for what x is sine of x equal to 0 on the interval 0 to 2 pi. So x is 0, or sine x is 0 when x is 0, pi in 2 pi. So those are all the places where sine is 0. And where is cosine 1/2? So cosine between 0 and 2 pi is, this is positive 1/2, so we're in the first quadrant and the fourth quadrant, right? So we need to find our reference angle, which is pi over 3, I believe. Cosine x equals 1/2 when x is pi over 3. Yes, so x is pi over 3, that's the one in the first quadrant, or the one in the fourth quadrant, so that will be 5 pi over 3. Alright, so those are my critical numbers. I have 1, 2, 3, 4, 5 critical numbers. So let's split up our number line into those values, and ideally we want to write them in order. So 0, pi over 3, pi, 5 pi over 3, and 2 pi. And these are all places where the derivative is 0. There were no denominators here or tangents, right? Any co-functions other than cosine. Any reciprocal functions like that have denominators. So tangent, cotangent, secant, and cosecant have a trig function in the denominator. We don't have any of those. So the derivative is not undefined. So at all these places, the derivative is 0. So those are then places where, and they are in the domain, so we're going to have local max and or local min at all of these places. And so now we use our test points, and we want to see what is f doing. So let's identify our intervals and then choose test points. So we can create the chart. So I'm kind of doing it both ways, right? I'm doing it simultaneously, having my number line and listing the intervals and the test points. You could just list the number line and pick test points as you go. So my intervals are then, well, it did say for between 0 and 2 pi, so I'm going to start at 0. So I'm going to say from 0 to pi over 3, and we can pick a test point there. You can pick pi over 6, and then sine of pi over 6. Pi over 6 is in the first quadrant, so this is going to be positive. And 2 times cosine of pi over 6. Cosine of pi over 6 is root 3 over 2, so times 2, you just get the root 3, right? So essentially you're going to have sine of pi over 6 times 2 cosine of pi over 6, which is root 3 over 2 minus 1. That's positive, it's 1/2, but mainly we're looking at the sign. Positive, and once you cancel these, you have the square root of 3 minus 1. Square root of 3 is bigger than 1, so that's going to be something bigger than 1 minus 1 is going to be positive. So that means this is positive, which means that the function is increasing. And then what about a test point between pi over 3 and pi? You can pick pi over 2. And so sine of pi over 2 is 1, so that's positive. And then cosine of pi over 2 is 0, so then you're going to have 2 times 0 minus 1, so that's negative. So that gives me a negative derivative. Negative derivative means that the function is decreasing. And then what about between pi and 5 pi over 3? I'm kind of picturing in my head the unit circle, so 3 pi over 2 is in between those. So now sine of 3 pi over 2, that's negative, and cosine of 3 pi over 2 is 0. So you're going to have a negative times a negative, which is positive. So on that interval, the derivative is positive, which means that my function is increasing. And then the last interval between 5 pi over 3 and 2 pi, what can we pick? We can pick, so pi over 6 will have to be, so 11 pi over 6. And sine of 11 pi over 6, that's going to be negative because sine 11 pi over 6 is in the fourth quadrant, so sine is negative there. And then cosine is positive, root 3 over 2, so we're going to have the same math over here, so that's going to be positive. So you have a negative times a positive, which is negative. So the derivative is negative there, which means that the function is decreasing. So where are your local maximums? So a maximum is when you go from increasing to decreasing, right? So that you have a peak. So this is going to be a local max, and your mins are the valleys. So where do we have another peak? So 5 pi over 3, you go from increasing to decreasing. So this is the reason that I like the number line, because I can see how it's creating the peak or a valley, right? So then this is a local max, and then here you're going to have, you go from decreasing to increasing, so this is going to be a local min, right? So this is where they occur. How would you find what they actually are? Plug them into the original function. So the local min will be f of pi. The local max will be f of pi over 3 and f of 5 pi over 3. So you need to find the y values if you're asked for what the local maxes and mins are. Where they occur, that's different. Those are the x values, where they happen. Okay? I'm going to record another video for the last example.